My name, I'm sorry. Okay. Welcome everyone. My name is Nikki Goldstein and I am one of the student moderators for this event, as well as the president of the Space Exploration Society here at NYU. It is our pleasure to have distinguished alumni, students, and panelists here with us tonight. We're recording tonight's program and it will be available on our website shortly after. Should time allow, we hope to take a couple of your questions.
Hi, my name is Shreya Thakur, and I am also a student moderator for today's event. I am also the Director of Operations for NYU Rogue Aerospace. We're a team that creates and competes rockets. We also wanted to thank Nicholas Mitchell and Robert Stevens from Lockheed Martin for their contributions to the event. And we'd also want to thank the Office of Alumni Relations for our partnership and making this event possible. We also wanted to thank our student organizations, American Association of Blacks in Energy, Hyperloop, Robotic Design Team, Space Exploration Society, and Rogue Aerospace. If you want any more information on our student clubs and organizations, you can find that in the chat, and you can also reach out to any of us for more information.
So our program tonight brings together a panel of incredible alumni who are working in aerospace all across the country. Space exploration and aerospace engineering affects us all, from the invention of the World Wide Web to combating the global climate crisis. This field isn't just science, it's human. If you look at this slide, you can see some of the inventions that affect our everyday life that we wouldn't have otherwise. Now, today's session features three amazing alumni: Daniel Carelli, Emily Muggleton, and John Zepay. We are honored to have them with us in this virtual environment to discuss this extremely important topic. Without further ado, let's meet our panelists. Daniel, if you could start us off.
Hi, yeah. So I went to NYU Abu Dhabi, but I did a year in New York in the Brooklyn campus, which was awesome. And right now I work at SpaceX as a hardware development engineer, particularly on Starship. So yeah, I mean, our express goal is to get humans to Mars and then beyond. So it's a great time.
Hi everyone, I'm Emily Mogleton. I graduated from NYU Tandon in 2018 in the Brooklyn campus. I'm still in Brooklyn, love New York, I cannot leave. I currently work at Collins Aerospace as a mechanical design engineer, and I work on environmental control life support systems, especially with the EMU spacesuit as well.
Hello everyone, my name is John Zepay. I graduated Polytechnic University in 1988 with a bachelor's degree in aerospace engineering, and after interning with the NASA Johnson Space Center while I was a college student, I started full-time, and I've been there. It will be 36 years at the end of February. I was the first lead structural engineer on the International Space Station, so I've had the opportunity to go all over the world and work with engineers from the European Space Agency, JAXA, Roscosmos, Canadian Space Agency. I've been all over the United States working with our aerospace contractors. And now I supervise 30 brilliant structural engineers in the structures branch at the Johnson Space Center. And we continue sustaining engineering on the International Space Station. We work on the Commercial Crew Program, Boeing and SpaceX's vehicles that are flying to the space station. We're also working on the Deep Space Gateway, which is going to be a station around the moon. We're working on the Artemis program to land humans back on the moon. And we have many, many other activities that we work on a daily basis to push aerospace structural technology forward. It's my pleasure to be here.
Thank you so much for those introductions. So I'll start us off with the first question. So how does space exploration affect the everyday person, and why should we as a society pursue it? And how can we communicate those benefits of space to a wider audience and cultivate a greater interest in the future of space exploration? So I'll let Emily take this one first.
Okay. I definitely think that space exploration is extremely important. I think it provides a lot of optimism. It gets people really excited about innovation. It really pushes people to their limits. One of the reasons that I picked aerospace and going into space is because when you're designing to the absolute extreme. You're designing to the most extreme environment. It's the harshest, the most strict requirements you're going to get. So when it comes to designing, you have to really, really think and become innovative and come up with something completely different that hasn't existed anymore. So I definitely think, going through and space exploration is extremely important in design, in optimism for everyone, and really just pushing people to think differently. And I think a really great way to communicate the importance of this is through events like this, especially in universities. I didn't get to be exposed to as much when I was at university. So I really had to go out and research it for myself and reach out to people myself. So having events where people who are already in the jobs that already have that credibility can come in and sort of give advice as well is really important.
Thank you. John?
In a free society, we have to decide what we want to do, what we want to invest in, what we want to work on. And the question that you ask is a question that I think has endured for almost the 60 years since President Kennedy gave his famous special message to Congress on May 25th, 1961, right after Alan Shepard's flight. And that's the famous speech where he said, we should commit the nation to landing a man on the moon and returning him safely to the earth by the end of the decade of the 60s. But there's another portion of that speech that I think is relevant to the question that you asked. And that excerpt is this. President Kennedy said in that speech, space is open to us now, and our eagerness to share its meaning is not governed by the efforts of others. We go into space because whatever mankind must undertake, free men must fully share. And of course, free women will share it as well. Forgive the vernacular of that time. We go into space to solve our problems on Earth. We go into space to inspire. We go into space to explore. The benefits that have come from space technology we're experiencing right now, where we have a network of computers and satellite feeds and internet connections that allow us to speak with one another. That technology came from the miniaturization of computers that were required to make the Apollo missions possible. There are many, many other benefits, and if you'd like to get an idea of some of the things that NASA does all of the time that affect your life today, I would encourage you to go on the NASA Spin-Off website. You can look that up on the web. It's NASA, obviously NASA, and Spin-Off, SPINOFF. NASA routinely shows how its technology is transferred to the public and all of the different benefits that are happening today in our society. An aggressive space program is important for our economic growth as a society. And the part about free men and women truly sharing these benefits is as relevant today as it was 60 years ago, because China is pursuing an aggressive space program. They have lunar ambitions. And we, as NASA, are leading the republics of the world, the Europeans, the Japanese, the Canadians, in exploring cislunar space with the Deep Space Gateway and landing on the moon with the Artemis program. It's important that freedom and that choosing to go into space is something that we do because the benefits are recognized by all and are available to all and are shared by all. And that has been the history of the space program since its inception.
Thank you. And lastly, Daniel?
Yeah, so I think that we've already touched on the main points, but I guess like if I had to boil it down, it's like there's three main reasons I think that we should embark on these endeavors. And like, I guess the first reason is obviously there's tons of services that these space companies have provided, ranging from GPS to weather prediction to agricultural services. And then if you take it a step further, as we're forced to design for these extreme environments that our spacecraft and our technologies are having to endure, like a lot of these technologies end up making their way and trickling down into common consumer uses. I mean, anything ranging from from materials like textiles to the computers. And I guess like the most exhilarating reason for me, like the most compelling reason, is obviously, I think it's ingrained in human DNA to explore, to go where no one's gone before, to see what no one's seen before. And I think that's really the reason that I do what I do every day. Yeah.
Great, thank you. Yeah, so we've really talked about how space exploration functions in our society, but kind of going off of that, what do you guys think are the largest challenges that will arise with it growing? And do you see it as a positive influence on the Earth's environment and kind of combating global climate change? And what could be done about this? John, if we could start with you.
Sure. NASA takes the lead in disseminating climate science data to the world, essentially, through the many environmental satellites that the Goddard Research Center, one of our NASA centers, really runs the Earth Science program for the agency and for the country. And the data that is generated from all of these climate missions are used all over the world, and they're used by land use experts and water conservationists and farmers and agriculture to deal with our changing climate and our changing environment. So NASA plays a pivotal role in disseminating the data for the policymakers and the scientists and the people who have to deal with our changing climate to make decisions about how to proceed and where to invest resources for the most benefit of mankind. And that's something that is wonderful about NASA's mission, that honestly doesn't get as much press as the more visible, more flashy, perhaps more imaginative human exploration or even deep space robotic exploration portion. And so again, NASA is not an agency off in the distance, disconnected from reality. It is something that is the American taxpayers pay for, and it's something that is there to provide services to the public. And the biggest challenge that I see ahead is essentially political will. As I said, we're a free society. We decide the things we want to invest in and what we don't want to invest in. And it's important that people who believe in NASA's mission, the whole range of NASA missions, from aeronautics to earth science to human exploration, robotic exploration, vote in representatives in the Congress that also share that vision of the future. Now, NASA is fortunate to have strong bipartisan support in the Congress, but that's not guaranteed. And our political process is such that our representatives decide the priorities of the nation and where they need to invest. So that's the biggest challenge that I see in the future, maintaining strong bipartisan support for the work that NASA does and making sure that the public really supports the kind of work that we do and makes their representatives know about that.
All right, thank you, John. Daniel, if you could go next.
Yeah, again, to reiterate, I think that the biggest challenge is obviously going to be getting buy-in from the public. It takes a massive amount of resources, time, and expertise to do the things that we're all trying to do here. And obviously like a lot of those resources end up coming from the government, and we need to get people to want to do this. That we want to get them to want to go, to Mars and beyond, and we want to get them to want to study the environment from space. We want them to be interested as we are, and I think the main challenge is getting them to that point. We've been accomplishing things in space, ever since Apollo 11, right? And even before that, but it seems like public interest has died. And I think that the main challenge is gonna get people as involved as they were back then. Yeah. And then obviously like the benefits for the environment are massive, right? Like we're able to understand our impact on the Earth because we've studied it from beyond. So.
Thanks, Daniel. Emily, if you could finish us off.
I agree, of course, with both John and Daniel. I'm going to take a slightly different take on this challenge. One of the things that I see being a very big challenge in the space industry is the transfer of knowledge. So there is a big age gap between all the amazing engineers that were around for Apollo, and they're in their 50s plus, and then there's a lot of newer and younger engineers coming in. So there's quite a big gap, because in between there was a lot going on, but not as much. It wasn't as intense, so there wasn't as many engineers. So right now we're going through the problem where a lot of these older, very talented engineers with hundreds of years of experience collectively of space exploration and engineering are starting to retire, or especially now with the whole economy, they're starting to leave and retire and being given separation packages. So we're not able to transfer that knowledge from these experts to the new younger engineers. So I'm very lucky that I was able to shadow an older engineer who is absolutely brilliant, but not everyone is having this opportunity. And also a lot of the older engineers aren't necessarily in having the time and availability to mentor younger engineers. They're the experts right now. Everything is moving fast. They're very focused on their new work. So one of the biggest problems right now is getting that knowledge before it walks out the door. Everyone is retiring, all that knowledge is disappearing, and we really need to capture and archive as much knowledge as we can so that we can learn and younger engineers can get that knowledge as well.
That was it.
Thank you so much. So our next question is, what trends in the space industry are you most excited to see play out in the future? So we can start with Daniel.
Yeah, so kind of along the lines of what I was saying before, the biggest challenge is getting people to buy into what we're doing. And I think that it's happening. I mean, I'm super excited to see that the things that used to make space prohibitive, cost and access, are very quickly going down. I mean, with the advent of SpaceX came several other small launch providers, which are also challenging the status quo. You have like companies ranging from Rocket Labs to Relativity to Virgin Orbit to ABL, tons of these awesome startups who believe that they can really transform the way in which we explore. And I mean, I think that's the coolest trend I'm seeing. This idea that we can challenge the status quo and we can do things better than we used to be able to do them. So yeah.
Emily?
Again, I agree. Getting everyone interested is really good, and also the trend moving into space tourism and having it being more accessible to the public is really interesting as well. Personally, I'm very interested in spacesuits. It's a niche that I was able to get myself involved in, and seeing people being more interested in suits and the commercialization of space, I personally would like to see more personalization with spacesuits, more customization for different types of customers. Perhaps like customers would be able to keep one of the spacesuits if they were to go into lower Earth orbit. There's so many different takes that people can go through with this, with the commercialization and more public people buying into it. So that's definitely what I'm interested in, and an exciting trend as well.
And lastly, John.
I'll follow up with between Daniel and Emily that space commercialization is the most exciting thing that's going on and will continue to be very exciting for a long time to come. I will put a cautionary note to the enthusiasm behind space commercialization. Right now, we have several very, very wealthy individuals who are supporting space exploration, and they have, with the resources that they have provided, in addition to the resources that the government provides them, have been able to shake up the status quo and do some very, very exciting things. The one thing that we have to remember, though, is that no matter who is behind space exploration, it is enormously expensive to do, even when you try to cut the costs and use reusable launch vehicles or reusable capsules or other things. The chances to send humans into space come infrequently and only one at a time. And the reliability of the systems that are required to sustain the human in space have to be extremely high. I had a mentor that said to me once, for hardware to be acceptable in space, it must work absolutely perfectly on the ground because space is an unforgiving environment. So the advent of commercialization will allow much greater opportunities for all different types of exploration. When it comes to human exploration, though, safety comes first. With launching satellites and other things, if a satellite fails, no matter how expensive the satellite is, you have insurance. Nobody dies. It's inconvenient, it's bad business, but there's a difference when you have human beings in flight, be they space tourists on a Virgin Galactic suborbital flight or the recent successful 2 missions that SpaceX has flown to the International Space Station. That is the fundamental difference when you're flying humans, that safety and reliability are going to be paramount in the continued expansion of commercialization of human spaceflight. And the success of commercialization of human spaceflight is going to depend on how private companies accomplish those two goals. Because if human life is lost on a commercial human space mission, that's going to set back all of space commercialization for human spaceflight.
All right, thank you. Yeah. So we actually kind of going a little bit further into space tourism and considering all those safety factors that you were talking about. How long do we see, like hypothetically, how long before it would be like family vacation, going to space? Emily, if we could start with you.
Space tourism has already started. There's companies such as Virgin Galactic that's sending people to lower Earth orbit, even if it's just for a minute or so and coming back down, but already sending people to the ISS. There's already tourists that have gone up or are going up in the next couple of years. I believe there may be a hotel module being developed to be sent up at some point, but I think it's coming soon. Affordability, on the other hand, maybe not quite there yet. Maybe for some very wealthy people, they may be able to go on a family vacation, but year-wise, I'm not quite sure. Maybe as fast as you can save money.
Thank you, Emily. John, if you wanted to go next.
I'm going to be a bit of a curmudgeon when it comes to space tourism. Axiom has just announced they're going to fly 3 individuals to the International Space Station. Each of those individuals is going to pay $55 million for the flight. And that is part of the policy to commercialize the ISS. I am concerned that these kind of missions will become what is happening on Mount Everest right now, where if you have enough money, you can book a trip to the top of Mount Everest, and there's a giant group of people, Sherpas and logistical folks, that are going to do a large part of the effort to help you get there. What I always love about NASA, and I'll always continue to love about NASA, is that if you can qualify to be an astronaut and work and be selected, it doesn't matter what your background is. You don't have to be politically connected. You don't have to be rich. You can come from any place in the world and you can fly in space. I get concerned that the initial part of space tourism will be sort of a rich person's hobby, something that they can check off their bucket list. Perhaps that's how it begins. That doesn't mean have to be happy about how it's beginning. I think it'll be a very, very long time before the safety and the reliability of the systems to fly to space and maintain the human in space will allow families to go in space and spend a month in space. That's going to be a long time. That doesn't mean it won't happen. It's just going to be a long time. Remember, space exploration is a generational process. Each generation builds on what comes next. My mentors got us to the moon and built the space shuttle. My generation flew the space shuttle, built the International Space Station, the Hubble telescope. The generation represented by our other two panelists, as well as many young engineers that I work with, are going to take our knowledge and move forward. So what I'll say is, I think those kind of things are inevitable when it comes to tourism, but it's going to be a while.
Thank you, John. Daniel, if you want to finish us off.
I think it's coming sooner rather than later. I've since starting to work at SpaceX, I think I've begun to subscribe to our timelines. And while they might be kind of outrageous, I do think that we are only getting started. I think that the pace of the technology is accelerating, and I think that probably, like was mentioned earlier, the first versions of space tourism are going to be more glamorous, much like how it was with commercial aviation, right? Like flying across the Atlantic was reserved for the wealthy. But over time, the prices came down as it became more commonplace. And I think we'll see similar trends to low Earth orbit, and even to even for suborbital flights. I think that it's important to challenge some of the assumptions that we've made in terms of how fast we can develop. Think back to Project Apollo and Project Mercury and Project Gemini. All of that technology was developed within about a decade, and they went from zero to the moon. And so I think taking the same aggressive approach, we can match that, especially with the technology that we have at our fingertips now. Yeah, I would like to see the democratization of space sooner rather than later, and I think it's around the corner.
I have something to add to this. I definitely agree with you, Daniel, that the technology is evolving extremely fast. I think one of the challenges I see is the training for the public, the type of people that would be going up to space. Because if you do look at there is a big disparity between the requirements to apply to be an astronaut versus the astronauts that are selected. So if you see the astronauts that are actually traveling up to space, all of them pretty much have a military background. They are trained extremely well to be able to think in fast, problematic situations on how to react and how to help themselves. I think that there is going to be a big change in how are we going to prepare the public on how to not feel claustrophobic or to not get sick, or all the training and being able, if something were to go wrong, how would they help themselves in that situation, and would they be able to think quick? I think that's one of the issues that would come up with more space tourism.
Yeah, and I think the burden lies on us as engineers to design systems that are ultimately safe and fault tolerant. Again, like I think we should be comparing ourselves more and more to commercial aviation. Like no one on your flight from Madrid to New York knows how to fly that plane other than the pilots. And yet we are all happy to sign up for that flight. So maybe it's not next year, maybe it's not the year after that, but with any grand technological challenge, you should have your sights on what the goal is. And I think the goal is to enable that kind of travel. So whereas now it's very difficult, and there are like a lot of unknowns when you go up to space. Like the Dragon vehicle was an engineering vehicle, right? The first one. You do want very experienced astronauts to go up there the first time. Same way that you wanted experienced pilots to fly your first airplanes. But I don't think we should hold that as a requirement forever. And I think the sooner we as engineers challenge ourselves to design systems that we would feel comfortable putting untrained passengers on, the sooner we'll achieve that goal.
That was a great discussion. So we're going to move on from space tourism. And I like this question because I'm not an engineer. I'm actually a business major in an engineering school. So we're aware of the role of astronauts and scientists, how they play in space exploration. But what are some of the non-STEM people you work with, and how do they affect what you do? We can start with Emily.
Okay, so I currently do not work with anyone that's not in the STEM field. I would love to. I work mainly with other mechanical engineers or test engineers, electrical engineers, but I think is extremely important as well, especially as things are evolving, especially the addition to the A in STEAM and having people that think more creatively as well, and just having a more well-rounded engineer is super important.
Thank you. John?
I don't know if anyone might have this fact off the top of their head, but Alan Bean, who landed on Apollo 12, I believe, with Pete Conrad, was a painter. And he has painted wonderful images from his space flight and many other things. And I have had the opportunity in my personal life, because Emily's right, most of the time we work around a lot of engineers. So you reach out and you deal with non-STEM people, mainly in your personal life. But it's important that if you think of Tom Wolfe, who wrote The Right Stuff, that writers, painters, songwriters, artists, that their imagination is captured by space exploration. And they propagate the message in ways that engineers simply can't, because we're trained and focused on making the systems work, actually building and launching spacecraft and keeping people and systems alive in space. And so, fortunately, in our society, and I've had the chance to go to Russia as well, and the amazing monuments that they have built to space travel dwarf anything we have here in the United States. It's embedded in their culture as a source of national pride to fly cosmonauts in space. It's that community, while not intimately involved in getting space exploration done, feels a connection to space exploration and is able to convey the joy, the sense of adventure, the majesty, the routine in film, in music, in art. And that's something that I hope continues. It's something that is such a wonderful way that that aspect, the human aspect, is conveyed through that kind of media.
Thank you. And then lastly, Daniel.
I don't directly work with many non-STEM people, but somewhat adjacent, there's some people who I appreciate a lot. At SpaceX, we have a really cool design team. Their job is to kind of take these engineering requirements and then turn them into something that's like more ergonomic and, you know, just more appealing to, I guess, the non-engineering type. And what they've really done a good job at rendering what this future should look like, at least aesthetically. And I think that's really awesome, again, because that all plays into this big challenge of getting the public bought into what we're doing. So yeah, I haven't worked with them personally, but I really do appreciate the stuff that comes out of their department. And then separately, again, like the media team, right? We have every time SpaceX launches, we broadcast that for better or for worse. And again, it's a way for people to feel like they're involved, so that ultimately they will get involved. Yeah, so really appreciate the work they do. And I think it's one of the most important aspects of what we're doing.
I'll follow up on what Daniel said. NASA has one of the rarest kind of government agencies in that almost everything that's done is completely transparent. You know, the launches, the activities on the space station, you can turn on the NASA channel and see what's going on in space. And it's always been like that. And SpaceX is broadcasting their launches, and you know, our SLS green run test where we had to shut down early a couple of weeks ago, that was broadcast. I think that gives people a stake in what's going on when you're transparent, when your successes and failures are public. They feel connected to what you do in a way that they're not connected to most of the things that the US government does. And I think that helps make people feel a part of what's going on with not only human space exploration, but obviously the robotic missions that give us the wonderful views of all the planets.
Great, thank you very much. That's actually a perfect transition because I was looking at a question. How do you see the role of humans and robotics with regards to space exploration evolving and growing in the future? And we can start with you, Daniel.
Oh man, like I sure hope we send robots before we send humans to a lot of these places. I think that they are probably going to be the first to make it to Mars. I think that's what I would do. And I think that there are some awesome opportunities to remotely set up camps and to set up bases before we actually send humans. So that's like your most futuristic version of robotics, right? But at the end of the day, like any autonomous vehicle or machine that we make is to some extent a robot. And so I think that we already use that type of technology a lot, and it's going to be increasingly used more and more. Yeah.
All right, thank you. Emily?
I agree. We already send up rovers, and moving past already setting up camp and using them to go before humans, also perhaps sending them with humans as well to help them as they go, to carry things. We already use rovers again, or just a car, essentially anything to help assist the astronaut already. I know that they already have a robotic arm on the ISS, so when they're doing spacewalks, the robotic arm can also help do some of the tasks so that the astronauts have more time to prioritize on different tasks and just help them out a little bit more as well. So anything to help out the astronaut.
All right, thank you, Emily. And finally, John.
I think all of the technology that's been mentioned, rovers and cars and those kind of things are going to be a part of human space exploration. But the best thing that I think is going to happen when it comes to robotics and human exploration is a continuation of the technology that NASA is developing around Robonaut. And for those who may not be familiar with Robonaut, you can Google everything you want about it, but it's one of the first robots that was ever designed in mind to actually assist an astronaut perform tasks with the dexterity of the human hand, have a visual system, and be able to be operated telerobotically. And Robonaut's prototype, it's been flown to the International Space Station. They're looking at flying another Robonaut up there to test it out. And I think the advancements in robotics that are going to be the most exciting when it comes to future exploration is going to be the robot that kind of looks like a human and can be able to robotically assist in extravehicular activities, maybe perform extravehicular activities, spacewalks by themselves without risking the astronaut. And being that kind of companion or that kind of helper, I definitely see that happening in the future, where you will have astronauts and then you will have robots that look like astronauts, and they will be working together.
Thank you. So our last of the serious questions are, what do you enjoy about your job and what makes you want to come to work and support this industry? And then what advice would you give to young people who want to get involved in the space industry? We're going to start with Emily.
One of the most exciting things about this job is that you get to work on the most extraordinary things. Sometimes some of the people that I work with, when they know that the ISS is passing over, they'll look up and they'll watch it and they're able to say something I designed or something I worked on is right there, and they get to see it float by. And eventually, hopefully, we'll be able to point at the moon and say, hey, something that I worked on is right there. And I think that's absolutely amazing. And going to work or logging into my computer now, every day the task is different. I'm not sitting down doing the same thing. Every day I get to do a different task. Every day I'm learning something new. Every day my head hurts. I'm learning so much, but it's definitely worth it. And it's super exciting. You work with the most intelligent people and you're always learning, creating something new. I don't think people really give it much credit on how creative an engineer has to be. I think it's very similar to an artist, how you're having to come up with something completely new. Even if it's iterating a previous design, it's a lot of creative work and it's super fun and I really enjoy it. Oh, advice. Okay. So if you are interested in going into the industry, the technical things can be learned. So don't stress too much about your classes. Yes, they're important, but don't stress too much. It's not the end of the world if you don't get an A. Technical knowledge can be learned. Communication, I think, is the most important. Being able to communicate with different disciplines, being able to communicate your ideas so that people can really understand, or being able to ask questions when you need it. And if you need help, being able to go out and ask for help. Don't be afraid to ask for help. Everyone is there to help you and to share their knowledge and to work together.
That's fantastic. John?
One of my earliest childhood memories, I must have been just about 5, was Apollo 17. It was the last Apollo mission. It was a night launch, and my parents let me stay up late to watch it. And I'm an old Trekkie. I also love Star Wars. There's no conflict in my mind between liking both Star Trek and Star Wars. I was always interested in space and space exploration. And I, of course, as growing up, naively set a goal of working for NASA. And I was fortunate to get a wonderful education at Polytechnic University. I was fortunate to receive a scholarship. They had a wonderful aerospace engineering program at the time, and I started interning at NASA. But that internship was very eye-opening because I would work a semester and go to school for a semester. And on my third semester, I started working in a structural engineering branch. I think I started on January 20th or 21st, 1986. And 1 week later, Challenger exploded. And I watched it from a conference room at the Johnson Space Center. That brought home the reality of the space program. It was not a fantasy. Humans were embarking on an endeavor full of risk and danger, and people die doing it. And I had to go through a very strong self-assessment. Did I really want to work in this industry, knowing what could happen? During my college years, I found that I enjoyed structural engineering the most. And I tell students the one piece of advice when I do outreach like this is you have to find your passion. You have to find the thing, be it aerospace, mechanical engineering, chemistry, physics, whatever, that you feel you enjoy doing and that you'll do it every day, because programs and projects will go. They'll stop, they'll get canceled, they'll come to fruition. You will have personal disappointments, you will have professional disappointments. The people you work with will come and go as you move through your career. But if you are working on something that you feel is what your life energy is meant to do, there are opportunities out there to do it. Now, you're going to have to find those opportunities. They will not be handed to you on a silver platter. You must look for the places where you will contribute based on what your passion is. And if you find what your passion is as you go through your college career and early into your professional career, and you find the place to do it, that will help you get through your life. And you will have a life that you can look back on and you feel that you've contributed to important things. I was also working for NASA when Columbia crashed in 2003, and the causes of both of those accidents are well documented. We don't have to discuss them here. But it brings home to you that you have an enormous responsibility, and everyone has those responsibilities, no matter what their job is. But space is an unforgiving environment, and it demands the best out of the people that work in it. And that's another thing that I love about my job, in that I get to work with the best people who are totally committed to the mission at hand, who sacrifice and are willing to put more than 100% into their efforts, working day to day. And that is not easy to do in any environment, let alone the space environment.
Thank you. And lastly, Daniel.
So, the thing that I enjoy most about my job, I think two parts: the quality of the people and the quality of the job. I think the people that I work with are amazing. That they're brilliant, they're energetic, and they're just as passionate about what we're doing as I am. Like you'll go fight with them and you'll argue, and you'll try to wrestle out requirements and so on. But at the end of the day, when a rocket would launch, everyone crowds around. Well, pre-COVID, everyone crowds around mission control, and we all yell, jump, scream, and cheer for that thing that we all just did together. And it happened like every 2 weeks at one point, and it was just amazing to see that we could all come together and build something and then watch it go to space. And everyone everyone is like that. Everyone is energetic and everyone seems to be brilliant. So much to learn from them. The other part, I guess, is the quality of the job. I think that it's really cool to, I mean, along the lines of what Emily was saying, like when I first showed up at SpaceX, my job was to qualify to test and qualify the Dragon power system. And so I spent, my first year and a half doing that. And then once that was done and it got integrated to the vehicle, I got to follow it along and I got to be in mission control for its mission. And I was a power specialist. So I got to monitor that thing that I spent my first 2 years, testing and qualifying. I got to monitor in space until it came back down. And then after it came back down, I got to be part of the team that took it back out of the vehicle and we got to, inspect it and see how it fared. And so I think it's a really cool job where you get to follow the thing that you've worked on from its inception all the way to, its purpose. So I think that's my favorite part of the job. Oh, and then advice. Yeah, I think it's extremely important to get out there and to just go build things, to go solve problems, to do things with your hands. I think that the best resource you'll have in university are project teams, whether it's, I remember Tandon had the Baja SAE team. That was one that I kind of wish I had signed up for, just because these SAE teams are super cool. They'll get out there and they come out with a car at the end of the year, which is amazing to me. The SES team that you guys have, I didn't really know about, but that seems really awesome as well. I'd say that like Emily was saying, like a lot of the textbook knowledge you can learn. I wouldn't worry too much about, acing all your exams. But the stuff that I think has the most value is your ability to go out there and to solve problems with your hands. Yeah. Work with teams, no one ever does anything on their own.
That was very inspirational, guys. Thank you so much for that. So now we have some more lighthearted questions, kind of going away from more serious ones. If you had the opportunity to be one of the first people on Mars, would you do it? Why or why not? And anyone can take this question first. So I'll leave the floor open.
Hands down, yes. I mean, I'd do it. I think that, yeah, I mean, it's the reason I'm doing what I'm doing. I wanna go. So yeah, I think it'd be amazing to be there, and someone's got to do it. Well, why can't it be me? So just keep working.
I would do it. On a grim note, if I go out, I go out big. So I'll do it.
Yeah, I mean, that was a dream, growing up for me, and the technology to go to Mars, though, is much, much harder than going to the moon. It would be an enormous investment, and it would have to be an international effort. And again, the political will would be needed to embark on a mission like that. But Mars is a challenge I think we need as a society, as humans, as a planet. I think it's something we desperately need. But it takes commitment. And it takes a long-term commitment and an enormous amount of resources. I hope it will happen during the lifetimes of some of the people who are moderating this panel or starting their careers. I don't know if that's going to be the case. But whether it does or not, you are contributing to the generational process of space exploration, like I talked about before. I've had a wonderful career, and I would go to Mars if they asked, but unfortunately, I am 55 years old, and I don't see the technology and the processes coming together during my lifetime. So it's not a question that occupies my mind anymore.
You never know. So our last question is, say you're traveling to the International Space Station for a year, just like our alumnus, Paolo Nespoli, class of '88, and you're allowed to bring a few personal items. What are you bringing with you? And we actually have an image of Paolo up in space with his Tandon gear. And anyone can take this first.
Well, let me just say I graduated with Paolo in 1988, and I've kept in touch with him throughout the years. Wonderful guy, and had an amazing life. Spending a year in space is brutal. I would recommend anyone who wants to get an insight into that is to read Scott Kelly's book, Endurance. And Scott Kelly is a tough, tough dude. And you read that book and you find how hard it is, even when you have the best training and you know, excellent physical skills and a support system with your family and your fellow crew members and on the ground, just what it is to spend a year in space. And I think for me, what I would enjoy, it'd be two things. It would be, first of all, I'd want to have a camera for myself that I could take pictures of the interior of the space station, and of course the Earth, that I could keep for myself, because that would be a wonderful a way to keep the memories alive. I'd also bring music because I think music would help keep me connected to an emotional side, and a connectedness with humanity. If you can imagine, if you're up on the space station, you're 6 people, and the other 6 billion are below you. So those would be the two things that I would take. I would take a camera so I can have pictures for myself, and I would take my favorite music to stay connected to life on Earth.
I guess I'll go next. I think I liked the along the lines of the camera. Something to be able to share the experience with people back down on Earth. I think that's what I would go for. Yeah.
Camera, sharing the experience. I really like the idea of music. Possibly my skincare routine. That's it, really.
All right, you guys travel light. So now we will go to our audience questions. Nikki, if you want to start us off with them.
Yeah, so going off of our first audience question that was handpicked, what are the main unsolved problems to make life in Mars possible? Anyone can take this one.
I think, Mars is hard. There's a great briefing called Mars is Hard by astronaut Stan Love. If you ever get a chance to see that, I think he did a TED Talk or it's a podcast or something. So I think it's out there. The main problem you're going to have going to Mars is simply the distance. You're going to be able, we will eventually, with the investment, have space nuclear propulsion, which will shorten the time to travel to Mars. We'll be able to solve the thermal protection system problem coming back from Mars because the velocities are very high. You're going to have life support systems. You're going to have suits. You're going to have all of that technology. The distance is the problem. And what the challenge going to Mars is, I think the biggest challenge, is the crew members are going to have to be able to work autonomously, because you're not going to be able to have the instantaneous mission control or the near instantaneous mission control support that you have going to the moon or staying in low Earth orbit. I forget the number exactly, but is it something like 15 minutes to get a message to Mars and get the message back? That's not going to help if you're in real-time situations that require real-time troubleshooting or everything else. So I think the hardest challenge that we're going to face, even if we surmount the technological challenges, which I think we will, is being able to give the crew the autonomy and the resources to solve their problems and work without the ambitious ground support that we have today.
Yeah, I guess to expand on that, harvesting resources on Mars is going to be hard, right? You'll need to power whatever systems you put down there. You'll need to figure out how to, grow food. You don't want to be sending food all the time. Radiation will be a challenge on the way there. Yeah, there's a lot of challenges, but I think that's what makes it fun.
On the spacesuit side, definitely the radiation is an issue. Will these astronauts even be able to leave the spacecraft? If they are, what type of spacesuits would they wear? They wouldn't be able to wear the moon or like the lunar spacesuits, since it would be different gravity. There's way more protections that they would need. So that would definitely be a big challenge as well.
And let me follow up real quick. I saw a comment flash by that I think we should address when we talk about Mars exploration. Initial explorations will be like Apollo, where we establish that we can do it, first of all, and then we can sustain life. But if you look at life off the Earth, and it doesn't have to be a Martian colony, it could be a lunar colony, it could be some settlement where large numbers of people come into place. That's going to be a much more difficult challenge, and that's where you need anthropologists and other folks to weigh in. If you look at the exploration of America, the earliest people coming over, a lot of those expeditions failed. The societies failed, and many people died because they didn't set up a societal infrastructure where you have decision makers and where you have farmers and where you have tradesmen and where you have the entire skill set and everybody knows their roles and that kind of process. And I think it was Jamestown that was one of the first settlements. Don't quote me on that. I'm not a historian. That actually worked in the New World. That, when you look at long-term exploration of the solar system, where we start with the moon or Mars, that's going to be an amazing challenge. How do you set up a sustainable group of people that know their roles and responsibilities, are willing to execute them, are willing to live together harmoniously, and make that colony work? I think that's an amazing challenge that we have just barely begun to scratch the surface in terms of actually thinking through how something like that would happen.
Haven't there been a couple analog missions where people stay together and they try and figure out the same thing that you were just saying? And even now, like with this pandemic, when everyone is quarantined, everyone's going crazy. So imagine being quarantined on the moon and not being able to go anywhere else.
And those analogs are useful, Antarctica analogs and those kind of things. But there's a difference when you think about space exploration or lunar exploration. I mean, even in Antarctica, even in the dead of winter, and people do get sick down there, 6 months or whatever, there's going to be someone to come to get you. Even on those deep sea analogs where people live in things under the ocean, well, they could always leave if there's a hurricane. That's not going to be possible on the moon. It's a completely different psychological paradigm. It's a completely different way of living. Even during the pandemic, God bless our technology that we've been able to do this. I mean, 10 years ago, we couldn't have even done this. Our technological infrastructure wasn't there to remote work or to communicate or those kind of things. If the pandemic had hit 10 years ago, we would be suffering even worse than what we're going through today. But when you are on the moon, when you are on a space flight, when it's a completely different thing that we have very little experience as humans thereabout, and that's going to be an extremely difficult challenge for the the generations that start that. And I hope the generation that's on this panel will have to confront that problem and figure out, well, we're going to send 50 people to the moon. How do we do that and make that colony successful? I believe, and I really believe this, that before the end of this century, we are going to have those kind of colonies on the moon. Mars is hard. I'm not going to say that about Mars, but it's certainly within the technological possibility to do that on the moon. The question is, how do you do that socially? How do we get a setup there to be able to do that?
That was a great discussion. So I know Emily talked a little bit about the kind of two different generations that are working in the space industry. We actually got a question about it. So seeing as there is intergenerational representation on this panel, how do the panelists foresee cross-cultural inclusion and youth engagement in space? Anyone can take this.
I want the younger members of the panel to answer first, and then I'll chime in at the end.
Cross-cultural inclusion. I think that this is a challenge for everybody, regardless of culture. I think that diversity is one of our greatest assets, and I mean that we should really lean on that, right? This is a hard thing that we're trying to do. We should use every tool we have in our toolkit, every person who's willing and eager to help. So yeah, I think that's the way to look at cross-cultural inclusion. Involving the youth, I think, is super important, again, just because got to get them when they're early. You got to get them excited when they actually might study this stuff, or they can make the decision to study this stuff. You can do that through competitions, through panels like these, through internships. But yeah, that's the challenge.
Definitely interesting when you're in university. There's all this support. It's a lot more diverse in university. And then you get to the space industry where everyone most of the time needs to have a US citizenship. So I was kind of shocked when I went into the space industry and it wasn't as diverse as I was used to. I grew up in London, very cosmopolitan. I live in New York, very cosmopolitan as well. And then going into the space industry, again, like, I'm used to being the only girl. It happens. I think the hardest thing is retention, keeping young people, diverse people, and having support for them in their jobs after they've already started is definitely something that needs to be more of a priority. There's times where I've been asked some ridiculous things, and there's times where I'm the only girl in the room, and people think they're helping. They're really trying. I'm definitely seeing more of an effort. Definitely, there's a lot of outreach as well. So there's definitely interest in the younger generation and more diverse, diverse backgrounds coming in, especially more immigrants coming in as well. So I'm absolutely ecstatic to see that. Like, seeing all the people from different countries now is really great, and people are supportive. So definitely just retention, making sure there's a support system. If you have any questions, there's people to talk to. I think that's really important. And also finding your group, finding people that you like to hang out with at work, more than just the people that you work with. But there are a lot of societies now that are starting to make clubs that weren't there before either. So you'll definitely find your group in there. It just takes a bit of looking.
Yeah, I agree 100% with Daniel and Emily. You have to give young people projects that get them excited early in their career if you're going to retain them. As I said, I managed 30 people. I've had the opportunity to recruit, of the 30 people that work for me now, 13 of them through their internships working for me. And I've had many others. I think I've had 32 or so interns, and of that, 13 of them have decided to come work for me, and I like that batting average. And to retain them, I gave them work on the most exciting stuff, from inflatable structures to the Artemis program to Mars entry vehicles. So you have to catch folks early in their career. When it comes to diversity and inclusion and cross culture and generation gaps, I have a somewhat unique experience in that I, at 27 years old, was made the lead structural engineer of the International Space Station. So I had to learn very quickly how to work with Russians, Europeans, Japanese, people from Florida, Alabama, California, Texas. I just had to do it. And so my experience being unique, you start to see the common threads through all people, and they're all motivated by many similar things. And it was a wonderful experience. And fortunately, at NASA, I've been lucky to have a great diversity of ethnicity, men and women engineers, and in my particular work group. So it's just easy for me because I've always been able to work in a diverse environment. And what you find is when you are around a group of diverse people, you see that the commonalities are much more prevalent and much more numerous than differences. And when it comes to generations, having mentored college students and brought them on to go work for me, and being a former college student myself and a former young person, every generation, every person, no matter who they are, and we'll talk about engineers because that's what we're talking about now, they want to know where they're going to contribute, where they're going to fit. How am I going to use my life energies? What am I going to do? What am I going to accomplish? Those are common across generations and across every person. So when young people come to work for me, there isn't a great generation gap, because just as I was a young college student who came to work for NASA and wondered all of those things, what am I going to work on? What's my career going to be? What am I going to accomplish? Where am I going to go? What am I going to do? Everybody asks those same questions. So from a generational standpoint, at least in my experience, very little difference at all. And I've just been fortunate to have a diverse workforce, to be in a diverse workforce. NASA encourages and diversity, and I've worked with innumerable number of people all over the world. And when you have the opportunity to do that, it really helps you look at the world and say, we're a lot more common than we are different.
I definitely think one of the good things that the space industry has is paid internships. It can help bring in people from different economic backgrounds and retain them as well. That's something that has been really good. I've seen a lot of people in different industries that don't have paid internships and are unable to do them. One of the big differences as well is location. So this is something that I struggled with when I was looking for a job. I knew that I wanted to work with spacesuits. I knew I wanted to work in the space industry, but all these jobs are in the middle of nowhere. And that is not where I wanted to live at all. And the job I currently have is actually in Connecticut. And people might think I'm crazy, but I drive 2 to 4 hours to get to my job. And that's because, to me, location is very important. And when I'm talking to a lot of younger engineers or people that are also in school and university and they're looking at jobs, they're like, oh, I really want to work in the space industry, but I don't want to live in Idaho. Like, they don't want to live in the middle of nowhere. And most of the time they end up leaving, or they'll start the job and after a year, the work-life balance is so important to them that they love their job, but after work, they don't have anything to do. So they end up not wanting to stay. And a lot of people end up going into finance to stay in New York. A lot of people end up going into HVAC, which was my first job as well, because staying in New York was very important to me. Or, there's now more space jobs in LA, and a lot of people are willing to go to LA, but location is a very difficult retention tool that I'm hoping now with switching to remote work, that this is something that could help retain younger employees. And even if it's going in once or twice a week, just having more flexibility in location, I think is definitely a big thing that can change the industry.
And Emily, I agree with you. I think remote work is going to change all industries, including the aerospace industry. There is a little bit of a reality there that you have to go where the work is.
Yeah.
You know, the work doesn't necessarily always come to you. Remote work was encouraged at NASA before the pandemic, and obviously we're all now working mostly remotely during the pandemic, and that will change the aerospace industry as it does every other industry. The thing about togetherness is that it breeds teamwork, and you can't work 100% remotely. I think we're at NASA, we're already working maybe 20-25% remotely before the pandemic to get the work-life balance that you described, and NASA encouraged that, and I think the industry now will encourage that even more because of what's going on in the pandemic. And when I came to Houston in 1984 for the first time, it was a cow town. I mean, I had a house and I could hear the cattle mooing in the pasture next to me and all that. But in the 35 years I've been here, it has developed into a cosmopolitan city. I mean, it's the fourth largest city in America now, and it's got theater, and it's got wonderful restaurants, and it's got music, and if you want to go to Austin, if you want to go to San Antonio, so I agree with you on location. It is very important, but I'd also say that there are always things to do wherever you go. You sometimes have to go where the work is, but I also feel that teleworking and the experience of the pandemic is going to open up the aerospace industry to more remote working. And for those folks who have a lot of needs and different needs for work-life balance, that definitely will play a factor in helping them potentially choose engineering or aerospace as a career.
Yeah, I think it's definitely a good step in the right direction. It's super important to be in person. For me, I do go in person before the pandemic to go to the lab and to see the spacesuits that have been brought back from the ISS to be refurbished, and you simply can't do that at home. But I would sit in 4 hours of traffic with a smile on my face because I didn't care, because I was going to go and see spacesuits. So it's still important to go in, but remote working has also been great. So there's definitely a balance there.
Yeah, I mean, wherever it makes sense, it really depends on your job, right? Like, there's no reason for software engineers to have to be in the office, right?
Yeah.
Most software engineers. But if your job is to be hands-on, then it's hard to be hands-on remotely without walking out with ITAR material. I don't know, like, can't bring that stuff home.
Yeah, amazing. As a young person interested in space exploration, like, all of your words were very comforting, and I hope to the other students that are watching this right now, they're very inspiring and comforting with going forward with space exploration. So in closing, since we're kind of getting to the end of our session tonight, we'd like to give each of you a few minutes actually, for your final thoughts and any just words that you want to put out there. So Daniel, we could start with you.
Yeah, I think it's going to be really important for us to not take everything for granted and to really try to push the envelope. If we're not failing every so often, then we're not pushing the envelope hard enough. I think we need to be okay with that, and I think that we need to challenge the status quo wherever possible, because that is how you bring about change, and change is what we're looking for.
All right, thank you. Emily, you go next.
I think for final thoughts, I want to give advice, or at least what I wish I would have done when I was in university, is to really what Daniel said earlier is to go out and just start making things. You don't need to have, you know, a 3D printer or anything, but just taking things apart, understanding how the world around us works, that really is super useful. And then you're able to apply that to anything that you do. That's one of the things that I've been learning now. And also just hang out with your friends, talk, learn how to communicate, maybe do a couple competitions. I really enjoyed participating in hackathons, and that is something that I learned a lot of skills that I use now, where it's coming together under pressure, working on a team and coming up with ideas and learning how to present them. I had so much fun doing that, and I think that it's a very useful skill to have as well. So just enjoy yourself. There's not so much pressure. Things will work out. I applied to 500 jobs for 2 years until I got the job that I have now. I graduated with a 2.4 GPA. You heard that right. And I still got a job in space. It's not the end of the world. It will be okay. School, as tough as it is, it will work out. Once you graduate, people do not ask for your GPA. I've never been asked my GPA except for the one job that I got asked for my GPA is the job that I currently have and the one I got. So it's going to be okay. That's it.
The GPA part was especially comforting. And finally, John.
The first thing I want to do is say thanks. I love doing these things and I've had a blast. Second thing I'm going to do is I'm going to give you my email, john.j.zipay@nasa.gov. If anyone on this panel or anyone listening wants to ask me questions about the space program or advice about how to get into aerospace or any of those kind of things, that's part of my job at NASA. I get paid to do that kind of stuff. That's what happens when you become a frontline manager. I think a couple of pieces of advice I want to give to the students and to folks is, first of all, when you embark on your career, particularly young engineers, everything has got to happen today. I urge you to have patience with the process of engineering, particularly aerospace engineering, but it goes to any kind of engineering, would it be civil, mechanical, chemical, whatever. There's an order and a method by way things are done and done properly. And that can be somewhat frustrating to young engineers who have a degree and they want to go out and change the world in the first year that they're working. If looking back on my career, I think I would have had a little less frustration early in my career if someone told me, just be patient with the process. These ways are put in place, these methods and these standards and these procedures are there so that things are done properly. They're not a barrier to innovation. I mean, ideas happen no matter what system you work in. But be patient with the process of working through things, designing things, building things, testing things, having failures, having successes. That's something I would urge a young engineer. Also, I would encourage you to do internships while you're in college. It is a competitive environment out for jobs, even in the broadly expanded aerospace industry that we have today. Internships, no matter where they are, it doesn't have to be at NASA, it could be any company or anything else, but internships show commitment. They show you're serious about the endeavor that you want to pursue, any kind of engineering. So I encourage you to do internships, look for opportunities to do internships. So when you're out competing for jobs, certainly when I look at resumes, I look at a person who's done internships. That shows to me a commitment to the discipline and the commitment to the work versus someone who may not have done internships. So I think that's very, very important. And then lastly, and I think this has been said a few times by our younger panelists, don't be afraid You're going to go out into the world. You're going to be in these jobs. You're going to be around people. You're going to do these things. Don't be afraid to speak up. Don't be afraid to challenge what's out there. Don't be afraid to fail. Don't be afraid to look silly at times. That's something that can be very difficult for a young engineer entering any field. But you're in the field. You're there for a reason. Your skills are valued. The things that you bring to the table are important. You're going to develop as an engineer when you're in your job, and no one expects you to do amazing things overnight. They're going to help you. They're going to mentor you. You're going to be given responsibility that you can handle, that the folks around you believe you can handle, and will help you along. So don't be afraid. Be bold. Be imaginative. Go into your job with enthusiasm, with energy. You will have disappointments. You'll have personal disappointments. You'll have professional disappointments. But as long as you keep up that enthusiasm, that will carry you forward. And those are the three things that I'd like to leave the audience with.
Thank you so much. So that just about wraps up our event. I'm going to hand it over to Valerie, who works at Alumni Relations, and she's been very vital in organizing this event, for some closing remarks.
Thank you. Thank you all. And if you don't mind, I'm going to leave my beautiful photograph up and not unvideo me. Good evening, everyone. My name's Valerie Cabral, and I'm the Director of Alumni Relations, the very proud Director of Alumni Relations here at Tandon. Before we close, I'd like to thank our impressive panelists, Daniel Carelli, Emily Muggleton, and of course, John Zepay, as well as our amazing, and I'm going to repeat it, amazing student moderators tonight, Nikki Goldstein and Sharia Takur. But you know, it takes a village, and we also have a team behind the scenes tonight and through all of the planning, and that's Michael Zhu, Alex Kelso, Jasmine Murphy, Angie Lara, Luisa Menendez, and of course, Alexandra Serret, who is my Assistant Director of Alumni Relations. On behalf of all of us, I have to say thank you, thank you, thank you for choosing to spend a Friday night with us. To find more programs like this, even though this was an amazing, amazing program, to find more programs just like this, watch for the NYU alumni website invites, and certainly watch for our special Tandon event invites. We do a lot of these, and now that we are doing it virtually, no matter where you are in the world, you're able to log in and join us for an evening. I also want to make a plug for the NYU Violet Network. If you're not a member, take some time and join. It's a great way to connect with fellow alumni, and of course, a sample you've seen tonight, connecting with our fellow students. They make my job a pleasure. We've put a lot of energy into this as a group, and it has certainly gone really well. I thank you all for joining us again tonight. I want you to stay healthy. I want you to stay safe. And I'm going to borrow a phrase. I'm going to say Godspeed and good night.
Good night.